So welcome to this latest video on 162 Maths, and in this video we'll be going over a GCSE Maths higher topic test on forming and solving equations. Now as always I'll include a copy of the questions that we go through in this video available for you to download by clicking on the link in the description, which I strongly recommend you do to test your prior knowledge on this topic. So let's get straight into this GCSE Maths higher revision topic test on forming and solving equations. So looking at question 1, let me just zoom in so we've got a better view of it on screen. It says Jean pays for gas, electric and water every month. Her gas bill is G pounds per month. Her electricity bill is £10 per month more than her gas bill. Each month her water bill is half of her electricity bill. Write down an expression for the total cost of bills for 1 year. Now the key aspects of this is the fact that initially we're told how much she pays per month, but we want our final expression to be 1 year. So first of all, let's start by converting each of these three utility bills as expressions of G. So her gas bill per month is going to be G pounds. Then her electricity bill, and that's for the month, is going to be £10 more, so that's going to be G plus 10. And her water bill is half of her electric bill. So if the electric bill is G plus 10, then her water bill will be G plus 10 divided by 2. Now these are what they were per month. So a bill for 1 month is going to be G plus 10 plus, and if I divide each of these things by 2, it'll be a half G plus 5. Now if I neaten all of that up, I get 2.5G plus 15. Now I want an expression for the bill for the year. So what I need to do is times all of this by 12. So it becomes 12 times 2.5G plus 15. And 12 times 2.5 is 30. And 12 times 15 is 180. Moving on to 1b, it says Jean pays a total of 1,830 a year for her gas, electric and water bills. Use the equation to work out how much Jean pays for electric for 1 month. So for this we know that the total expression, which we wrote for part A, needs to add up to 1830. Now if I go on and solve this equation, I get 30G equals 1650. So then G equals 55 when I divide by 30. So then her electric bill is equal to G plus 10, which is going to be 55 plus 10, which is 65. Now moving on to question 2a, it says I think of a number, I multiply it by 2, add 1 and the answer is 4 times the original number. Form an equation to show the relationship between the original number and the answer. Well, if I call the original number n, then multiplying it by 2 and adding 1 looks something like this, and the answer is 4 times the original number, which is n, so it's 4n. So then my answer is just that. Now if you chose a different letter, that's absolutely fine, but you should definitely end up with 2n plus 2 something plus 1 equals 4 something. And you can write that as in either way. Moving on to question 2b, it says solve the equation to find the original number. So for this, what I had to do was 2n plus 1 equals 4n. So when I've got n's on both sides, I want to take them all onto one side. So I've got 1 equals 2n. So therefore, n equals a half. So it's 0.5. Moving on to question 3, it says the teacher asks her class to write in a question that involves both algebra and geometry. This is Shanana's question. A hexagon has interior angles of 5x plus 5x plus 4x plus 3x plus 2x plus 1x. Work out the value of x. Answer Shanana's question. So first of all, we know it's a hexagon, so we know that the total sum of angles in a hexagon are going to be the number of internal triangles, which is 4 times 180, which is 720. So therefore, what I've then got is 5x plus 5x plus 4x plus 3x plus 2x plus 1x equals 720. So simplifying all of that, I get 20x equals 720, and then take the 20 over, so x equals 720 divided by 20, which is 36 degrees. It then says comment on the solution to Sanana's question, and the problem is that x cannot be 36, as this would mean two angles, in other words the ones that are 5x, being 180 degrees, so therefore a straight line. This would imply the shape is a quadrilateral rather than a hexagon. So something along those lines would be good enough for that one single mark. Moving on to question 4, it says the shape is made from a large semicircle with a radius of capital R and a small semicircle with a radius of little r, joined as shown. And the question is asking us to work out an expression for the perimeter of this shape. So first things first, let's just highlight each of the sides of this particular shape. So here I've got this orange length. Well, to work that out, that's going to be 2 pi times the radius, which is capital R. And because it's a semicircle, I divide that by 2. So then the 2's cancel out. So all that orange length is going to equal is pi capital R. If I do the same with this smaller semicircle arc, then that's going to equal 2 pi little r divided by 2, because it's semicircle. The 2's cancel out, so it's just equal to pi little r. So all that's left for me to do is work out the two straight lengths. So this length here is equal to little r. Now in terms of the other length, that's based on two sections. So this bit here is capital R. And picking a colour that I've got left, which is green, and this length here is going to be the big, well, all of this would be blue, so that's going to be capital R, but I'm taking away little r. So this little length here is going to be big R minus little r. Alternately, what you could have done is basically moved this length here, and if I move that there, that would therefore just equal capital R. So again, just be mindful of that. So then all that's left for me to do is to add all of those sides together. So I'm adding this side plus this plus this plus this plus that. So then here the perimeter, so P equals, if I start going in this direction, I've got pi capital R plus little r plus pi little r plus r minus little r plus r. Then if I take that bracket out, I get pi capital R plus r plus pi r plus capital R minus little r plus r. Then I should have some things that cancel out. So here I've got this little r will cancel with that, and I can join those two r's to make 2r. So the final answer is going to be pi capital R plus pi little r plus 2r. And that equals P. Now moving on to question 5, it says the rectangle and the equilateral triangle have the same perimeters. Work out an expression in terms of x for the length of the side of a triangle. Give your answer in its simplest form. So the first thing I need to do is work out the perimeter of the rectangle. So if this side is 3 lots of x, 4x plus 2, then if I just simplify that, that's going to be 12x plus 6. And if I simplify the height, that's going to be 6x minus 12. So then working out the perimeter of that shape, well, that's going to, of the rectangle, it's going to be 2 lots of 6x minus 12 plus 2 lots of 12x plus 6. So then expanding the brackets, I get 12x minus 24 plus 24x plus 12. And simplifying all of that, I get an answer of 36x minus 12. Now that's what the total perimeter is. So therefore, side on the triangle, which has got 3 sides, is going to be 36x minus 12, all divided by 3. So if I divide everything by 3, that becomes 12, that becomes 1, and that becomes 4. And it gives me my final answer of 12x minus 4. Moving on to question 6, it says the diagram shows 2 rectangles. All dimensions are in centimetres, and it says work out an expression in terms of x of the shaded area. Give your answer in its simplest term. Now the shaded area is the area of the big rectangle minus the area of the small rectangle. So working out the area of the big rectangle, well, that's going to be that times this. So the big area, so just call it big rec, that's going to be equal to x times 5 lots of 2x minus 1, which is 5x 2x minus 1, which is equal to 10x squared minus 5x. Then if I work out the small rectangle, that's going to be 3 times of x plus 1. So that's going to be 3x plus 3. So that means then the shaded area is going to be those two things take away. So that's the big area, which is big rectangle rather, minus 3x plus 3. Then neatening all of this, we get 10x squared minus 5x minus 3x minus 3. And then combining each of those, we get 10x squared minus 8x minus 3. Then moving on to question 7, it says the diagram shows 2 rectangles. All dimensions are in centimetres. The shaded area is 84.5. Work out the perimeter of the white rectangle. So here, again, the shaded area equals the area of the big rectangle minus the area of the small rectangle. So working out the area of these, well, the big rectangle is going to be 7 lots of 2x plus 3, which is 14x plus 21. The small rectangle is going to be 3 lots of x plus 1, x minus 1 rather, which that's going to be 3x minus 3. I then need to take those two things away, so the shaded area is equal to 14x plus 21 minus 3x minus 3, and that equals 84.5. So then if I neaten this up, I get 14x minus plus 21 minus 3x plus 3 equals 84.5. And then if I neaten it further, I get 11x plus 24 equals 84.5. And then so 11x equals 60.5, so x equals 5.5. Now the question doesn't ask me to find x, it asks me to find the perimeter of the small rectangle. So then the perimeter of the small rectangle is going to be 3. It's going to be these lengths added together. So that's going to be 3 plus x minus 1 plus 3 plus x minus 1. Now because I know that x equals 5.5, then I end up with 3. 5.5 take away 1 is 4.5 plus 3 plus 4.5. and that comes up to a total of 15 centimeters. So I could just write 15 there. Then moving on to question 8, it says, here is a rectangle, the length is 3x minus 1, the perimeter is 10x, write down an expression for the area in the form of ax squared plus bx plus c. So looking at this, we know that this, if the top is 3x minus 1, then this bottom is going to be 3x minus 1. Now if I just write y for these two sides here, then what I've got for the perimeter is 3x minus 1 plus y plus 3x minus 1 plus y equals 10x. Now if I neaten and expand the brackets, I end up with 6x minus 2 plus 2y equals 10x. Now I want to work out what y is, so if I take the 6x out to the other side, I end up with minus 2 plus 2y equals 4x. So 2y equals 4x plus 2, so y equals 2x plus 1. So then I can write this as 2x plus 1, that is 2x plus 1. So then working out the area is going to be equal to 2x plus 1 multiplied by 3x minus 1, and that gives me an expression of 6x squared plus x minus 1. Then moving on to our last question, it says here is a rectangle, the length is 3y minus 2, the area is 6x squared plus y minus 2, and it says work out the expression for the width w in terms of y. Now for this, basically what we've got is we've got w, well w is going to be something a y plus b. It's going to be something that looks like this, where a and b are going to be numbers. Now there's a couple of ways in which we could do this. So if I look at 3y minus 2, and let's say I set up my second bracket, and I know this has got to equal 6y squared plus y minus 2. Now the only way of me getting 6 when I'm, oh, don't know what I did there. The only way of me getting 6y squared, knowing that one of the terms has got to be 3y, so what do I have to multiply 3y to get 6y squared? Well, that has to be 2y. Now in terms of looking at the minus 2, the only way of me getting minus 2 when I've got minus 2 is multiplying it by plus 1. So there you can see that this must equal what w is. So w equals 2y plus 1. Now another alternative is if I use this, and now I'm going to end up with something that looks like this, and I'm going to multiply it by that. So I end up with ay plus b multiplied by 3y minus 2. Now that all equals 6y squared plus y minus 2. And it becomes comparing coefficients. Now this is just an alternative of getting the same answer. Now if I expand the brackets, I get 3ay squared minus 2ay plus 3by minus 2b. Now in terms of comparing the coefficients, I've got 3a must equal 6, so therefore a equals 2, and here I've got minus 2b must equal minus 2, so therefore b equals 1. So then if I substitute these two things into this here, I end up with 2y plus 1, which is exactly what I've wrote down as my final answer.